Asterisk, the green visitor, an interstellar mystery unfolding before our eyes. As a physicist, people ask me all the time, when will we discover something truly extraordinary in space? And I always tell them the same thing. We already have. Right now, at this very moment, something remarkable is happening in our solar system. Something that's forcing us to rewrite our understanding of the cosmos. Its name is Comet C, 2024 S1 Atlas, but I just call it the Green Visitor. And let me tell you, this is unlike anything we've ever seen before. A cosmic detective story begins. Picture this. It's July 2024. Astronomers are scanning the night sky when they spot something unusual. At first, it's barely visible, just a faint whisper of light, so dim you could easily mistake it for background noise. Most people would ignore it, but scientists don't ignore whispers from space. We listen, and what we heard next was absolutely stunning. This tiny dot of light began to change. Week by week, it grew brighter, not gradually, especially by October. This visitor was blazing across our solar system at nearly 60 kilometers per second. That's 135,000 miles per hour. Fast enough to circle the entire Earth in less than 20 minutes. But here's where it gets really interesting. This comet is glowing green. A brilliant, emerald green that shouldn't exist, according to everything we know about cometary physics. The mystery of the green glow now. You might think, okay, green comet, so what? But this is where the detective story begins. You see, when comets glow green, we know why. It's chemistry. The sun's ultraviolet light hits molecules of diatomic carbon. We call them C2 molecules, and they emit that characteristic green color. We've seen this dozens of times. It's predictable. It's understood. Except, when we pointed our spectroscopes at Atlas, we found something shocking. There's almost no carbon. Let me repeat that. The green glow we're seeing shouldn't be there. This is like watching a fire burn without fuel. It defies our models. It challenges our equations. And that, my friends, is when science gets exciting, because when nature breaks the rules we thought we understood. It's telling us there's something new to discover. Racing toward the sun. Right now, ATLAS is on a collision course with destiny. On October 28th through the 31st, it will make its closest approach to the sun, what we call perihelion. It'll pass within just 0.36 astronomical units of our star. To put that in perspective, that's closer than Mercury's orbit. This frozen visitor from interstellar space is about to dive into an inferno. At that moment, it'll be traveling at 68 kilometers per second. The sun's radiation will be 7.7 times more intense than what we experience on Earth. The surface temperature of the comet could reach hundreds of degrees Celsius. What happens next? Nobody knows for certain. Will it survive intact, emerging triumphant from the flames? Will it fragment into 1,000 glittering pieces, each one a fragment of an alien solar system, or will it erupt in a final blaze of glory before fading into cosmic dust? This is the beauty of science. Sometimes, we simply have to wait and watch. The Mars connection. But here's where this story takes an incredible turn, one that shows you just how far humanity has come. On October 2nd, NASA's Perseverance rover was conducting routine night photography on Mars. It was capturing star trails, beautiful arcs of light that stars make as they move across the Martian sky. And there, in the images, was something unexpected, a diagonal streak, a narrow line cutting across the frame. At first, engineers thought it might be a cosmic ray random radiation that sometimes hits camera sensors, or maybe a satellite. But when they checked frame after frame, the streak was still there, and it was moving in exactly the direction that Atlas should be traveling. Think about what this means. A robot we built, sitting on another planet 140 million miles away, may have photographed an interstellar visitor passing through the Martian sky. This is the first time in human history, that we've potentially observed an interstellar object from two different planets simultaneously. A geometric miracle. Now here's where the universe threw us a curveball and a blessing at the same time. On October 21st, Atlas passed into what we call superior conjunction. That's a fancy way of saying it went behind the sun from Earth's perspective. For weeks, we on Earth couldn't see it at all. It was lost in the sun's blinding glare. Under normal circumstances, this would be a disaster, the most critical moment of the comet's journey, and we'd be blind. But remember Mars. Remember that photograph from Perseverance. Here's the miracle. When Atlas disappeared from Earth's view, it remained perfectly visible from Mars. The geometry of the planets aligned in such a way that Mars-based instruments orbiters like MAVEN, Mars Express, and the ExoMars Trace Gas Orbiter could continue watching while Earth's telescopes fell silent. It's almost as if the universe planned it this way, as if the cosmos wanted to test whether we'd grown wise enough to use multiple observation posts across the solar system. And we passed the test. What the light curves tell us. As a theoretical physicist, I spend a lot of time looking at graphs and equations. And let me tell you, the light curve of Atlas, the graph showing how its brightness changes over time, is one of the strangest I've ever seen. When the comet crossed inside 2 astronomical units from the sun, something unexpected happened. The brightness suddenly jumped. not smoothly, but it began oscillating, growing brighter, then dimmer, then brighter again in unpredictable rhythms. This shouldn't happen. Our models predict smooth, gradual changes as a comet approaches the sun. So what's causing these fluctuations? We have theories. Maybe new vents are opening on the comet's surface, releasing jets of gas and dust as the ice sublimates. Maybe there are electrostatic discharges in the plasma surrounding the nucleus like lightning storms in space. Or maybe, just maybe, we're witnessing some form of interstellar chemistry that's never been activated by our sun before. Whatever the answer, the comet is trying to tell us something. We just have to learn its language. The bigger picture, 3 visitors. Step back with me for a moment and look at the bigger picture. In less than a decade, 3 interstellar objects have visited our solar system. First came Oumuamua in 2017, that strange, cigar-shaped object that tumbled through our solar system and accelerated in ways we still can't fully explain. Some scientists think it was an interstellar asteroid. Others propose it was a piece of alien technology. We still don't know. Then came to I Borisov in 2019, a more classical comet, complete with a tail, clearly formed around another star. And now, Atlas, the brightest and most enigmatic of them all. 3 visitors in 10 years. Think about that. For all of human history, thousands of years of watching the skies, we never confirmed a single interstellar visitor. And now, in less than a decade, we've found 3. Either we've just gotten incredibly lucky, and this is what I believe, the galaxy is filled with these wanderers. Trillions upon trillions of rogue comets, asteroids, and planetary fragments drifting between the stars. A vast ocean of debris from billions of solar systems, sailing silently through the cosmic dark. We're just now learning to see them. The December reveals, so here we are, waiting. By early December, Atlas will emerge from behind the sun. It will reappear in Earth's dawn skies, transformed by its passage through the solar fires, and we'll finally get our answers. Has the mysterious green glow persisted, or has it changed to something else entirely? Has the comet survived intact, or are we now tracking a family of fragments? Has its brightness dimmed, or has it emerged even more luminous than before? Telescopes across the world are ready. Observatories from Chile to Hawaii to South Africa are preparing their instruments. Scientists are clearing their schedules. And missions like ESA's JUICE spacecraft, traveling deeper into the inner solar system, will continue monitoring even after Atlas fades from view. The data from this encounter might not be fully analyzed until 2026, because science isn't fast, it's thorough. Every measurement must be verified, every spectrum cross-checked, every theory tested against the evidence. But that's okay. The universe has waited billions of years to show us this moment. We can wait a few more months to understand it. What this means for humanity. You know what amazes me most about this entire story? It's not just the comet itself, it's what the comet represents. 100 years ago, we could barely see beyond our own planet. 50 years ago, we just landed humans on the moon. And now we have a network of telescopes and spacecraft spread across 2 planets, all working together to study a visitor from another star system. We're coordinating observations across 140 million miles of space. We're using artificial intelligence to process data we're combining spectroscopy, photometry, orbital mechanics, and plasma physics to decode the secrets of an object that's spent millions or billions of years traveling through the void. This is the power of human curiosity. This is what happens when we refuse to accept "I don't know" as a final answer. Atlas didn't just arrive to be observed. It arrived to be understood. And in trying to understand it, we're becoming something greater than we were before. The question we can't avoid now. I have to address something that some people have been asking, something that borders on the edge of mainstream science. But we can't ignore it. Could Atlas be something other than a natural object? I know how that sounds, but hear me out. Asterisk.